We're going to be looking at an emulation of a Turing Machine 11.14 in the Intro to Theory of Computation by William. This problem is asking us to consider the following TM with input alphabet 0, 1. Now you can't see the TM specifically, but that is the graph that is given to us. And so we're going to need to create that in code first, and then we're going to need to answer a few questions about it. So first thing we do, we create the tape. Then we add our first delta. We append all the letters of the given string. And then we also append an X at the end to represent that delta, to represent that double-sided infinite tape. Now, we start the tape with the first number of the string. We have a pointing index at 1 for the tape, and we start at state 1 to read. We again start this infinite loop that just keeps running and running until we break or we get to that accept state. Now, in the first state, we move left. If it's a 1, we switch to state 2, but we keep that 1 there on the tape. Now we know with this problem there's a tricky infinite loop at the beginning, which I need to catch for the program's sake. Otherwise, we would have a very long infinite loop and we wouldn't be able to find a valid solution to the problem. So in order to catch that, by looking at the problem, we need to know that this infinite loop occurs in this Turing machine when we read in a 1 and then we read in a delta from state 1. So what we do is we have this previous check here, so that way if we're in state 1 and we read in a 1 and it's true, and then we can see further down here that if the index is x and from state 2, if the index is x and the previous was true, that previous one was true, then we know it's false. We encountered that infinite loop that's going to occur. If we read in a 0 from state 1, then we're going to set our value to the money sign, and we're going to move to the right, and we're going to go to state 3. Then if we read in x, then that is going to bring us to our accept state, and we're going to accept. From node 2, if you read in a 0 or a 1, they remain the same, but the pointer dies because there's nowhere for it to go. However, from state 2, if you read a money sign, then it changes to a 0, and we move to the left, but we remain in the same state. If we read in this delta, we talked about this and how we can catch ourselves in an infinite loop, but not necessarily all the time. And that's why we have this little check here to see if the previous one was actually a 1. So now we move on to state 3. So if we read in a 1, we move right and we go to state 4. Then if we read in a 0, we move right, but we just stay at that state 3. And then otherwise, you don't have any pointers going anywhere, and therefore the pointer dies. Then we have state 4, which states that if we have a 1, then we stay at 1, we stay in that state, but we move our pointer to the right. And the only way to get out of that state is by reading the delta, and then we move to state 5, we move our pointer to the left, which is why we're subtracting from the index, and then we know that if we get a 0 or a money sign, we die because our pointers are no longer pointing anywhere. Then in state 5, the only way to get out is if we read in a 1, which then we change our tape at that point to a delta. We move to the left, and we also move to state 6. In all other cases, we have no other options and our pointer will die there. Then we look at state number 6. State number 6 says that if we have a 1 or a 0, the pointer will always move to the left 1 spot, but we will stay in the same state and the values will not change on those tapes. However, if you read in a money sign, then we will replace that with a money sign. We will move to the right and we will switch back to state 1, which allows us to go reach that accept state again. Finally, if we do read the delta in that 6th state, then it will have to die because there's no pointer for it to go. Now we can run this on the questions that we have and see what. Uh, so, so our first question was, what happens to the Turing machine if the first symbol of the input is a 1? So this gets us into this infinite loop. If we have an infinite number of deltas before, an infinite number of deltas after, and then we have a 1, then we know we get stuck in this infinite loop, and then we will get caught. So it returns false because it is not accepted. What is the final string if the input is 0011? So if you look at 0011, you can see that our final tape looks like that, with a delta, money sign, delta, 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 and these deltas again go on forever on both sides, with our pointer pointing at the 3rd position, and this string it accepts. Then it's asking us which 4 symbol strings does the Turing machine accept. So if you run a test on all of the possible 4 symbol strings, then we will see that these are the final tapes for all of them. These are where the pointers were pointing. And we can notice quickly that if it ever starts with a 1, we're going to run into that infinite loop because we're going to read a 1, we're going to move to the left, we're going to see a delta, then we're going to move to the right and read a 1, delta and 1. And so we already know that from that first question that these are all going to fail. So if you look at which 4 symbols are accepted, it's 0011, which was that one that we looked at before, and 0111.